So we are live. Welcome to the March Defensio, the Synthetic Landscape Lab, Institute of Urban Design, Innsbruck University. Today we will see 3 students that are supervised by myself, Claudia Pasquero, together with Maria Capsova. Thanks to our guests, Melanie Fessel and Melissa Sterri. Melanie is an architect, urban designer. She's lecturer, academic coordinator, and doctoral researcher at the ETH Zurich Department of Architecture. Melanie is principal investigator of open network ecology, and she is lead member of Terraform Network in Europe. Melissa is a transdisciplinary design scientist, complex system theorist, biofuturist, multi-award-winning serial entrepreneur and innovator, as well as chartered scientist. Marco Paletto is a director of Ecology Studio, design innovation company. He also practice-based doctorate at the MIT Europe, and is visiting lecturer here, as well as our external examiner at Innsbruck University. So thank you. Today we have 3 candidates, Daniel Stiletto, Sebastian Partner, and Thierry Lopez. Maybe we can start with Sebastian.
Okay, let's start. Hello to everyone and welcome to the presentation of my master thesis project. My name is Sebastian and the project is called Akpobloshi, the landfill as landscape. And it's a project with the aim to come to a new form of landscape that can counteract a certain type of environmental pollution. Akpobloshi is the site where it takes place. And this over 1 kilometer long factory in China is representative for the ever increasing mass of products. This mass brings an ever larger amount of waste that has to be disposed. The burden to the environment is increasing. The recycling is becoming more and more important, and due to the mass, it's not possible to properly dispose of all the waste produced. And that's why illegal landfills are emerging, particularly in poorer regions, which are exposed to uncontrollable pollution. And this project deals with one of these locations, Akpobloshi, a district of the Ghanaian capital, Accra, is a very special place as it is one of the largest illegal e-waste landfills in West Africa. E-waste from around the world made Akpobloshi to one of the most contaminated areas. The poor conditions do not allow proper recycling. The e-waste is recycled through collecting, dismantling, and burning them to get available metals. This releases toxic substances that are very harmful to both people and environment. The pollution affects the soil, air, and groundwater. And the first part is about dealing with the pollutants caused by the e-waste. One method the project is dealing with is particle accumulation, in which particles of contaminated air can settle by hitting solid surfaces. The second method is called phytoextraction and refers to the plant's ability to take in heavy metals from contaminated soil and groundwater and store them inside their parts. These plants are called hyperaccumulators, and to remove the pollutants from the site, the plant must be harvested. To get a sustainable solution, a combination of these 2 mechanisms is used for the project. And to get the basis for the application of the remediation mechanisms, a technique for transforming a landscape is determined. And water is defined as the main influencing factor. And the focus is on finding new patterns. By simulating hydroerosion, A starting terrain is manipulated in several steps. And two different approaches were tested. And the knowledge gained from these simulations will be applied in the next step, the site transformation. And the aim is to create a new topography for the Akropolossi landfill in order to get new conditions. And the first step is the import of the satellite image to localize the areas covered with e-waste. This is followed by several erosion processes and zoom-ins to cause a manipulation of the original topography. In the first transformation scale, a new morphology on the localized e-waste areas emerges. By zooming in and further erosion processes, new details and patterns emerge. With a final hydroerosion in the last transformation scale, the new topography is created. The generated morphology is defined by terraced elevations in form of many small plateaus that run through the entire area. The outcoming geometry of the last transformation scale is used for further processing. The task of the new morphology is to counteract the pollution of Akropolossi, and this is done by implementing the remediation system in form of accumulation walls and extraction pools. And the accumulation walls have the function of catching the pollutants from the contaminated air and depositing them on their surfaces. To find the suitable areas, a particle simulation is applied. The particles spread constantly until they collide with the geometry. There they start to accumulate. In this way, those areas of the landscape can be localized where the particles can be deposited. In order to find the optimal surface for maximum particle accumulation, two different surface structures are subjected to a further particle simulation. And the comparison shows that in geometry B, significantly more particles accumulate than in geometry A. And geometry B was manipulated by fractalizing the individual phases. And the integration of the accumulation walls takes place in 3 steps. First, the landscape is scanned using a smartphone to localize the suitable accumulation areas. Next, a print robot is used to create the accumulation bundles for the scanned areas. The print material should be made from the recycled components of e-waste. The prerequisite for this is a suitable production by the manufacturer. And finally, the panels will be installed by the people into the landscape. And as the pollutants collected on the panels are washed off by the rainwater, further pollutant remediation takes place with the help of extraction pools. For this, analysis of water distribution are used to localize those areas where the most contaminated water seeps away. These areas are transformed into pools. The pools serve as collection points for the contaminated water and planting areas for the hyperaccumulators. The task of the extraction pools is to clean the surface water and the soil in the immediate vicinity of pollutants. And the proposed landscape for the Akropolossi landfill is defined by the eroded topography with its accumulation walls and extraction pools. This creates new conditions for Akropolossi, wherever pollution from e-waste recycling occurs, it is possible to react in the immediate vicinity. And through the interaction of people, the new topography, as well as the accumulation walls and extraction pools, pollution of air, soil, and groundwater can be reduced. Thank you for your attention.
Thank you.
Thank you, Sebastian.
do we want to open up to comment?
I would just like firstly to say that I've been aware of this particular site for a number of years, and it is a truly devastating pollution issue, both at the site itself and regionally. So it's absolutely wonderful to see that you have taken this problem. I've been looking out for a long time to see people actually address it. And you've come forward with a solution which I think is very well researched. You've looked in detail at the flows. You have a real sense of the complexity of this issue. You have come up with a solution which, although technically has some unanswered questions, I think is very much in the right ballpark, in that you've looked to something that is both, it's a two-part solution. So it's you're not saying that a one-stop shop, as it were, is going to solve this problem. And you've also looked to something, you mentioned that this is something that the local community would implement, and therefore, you've thought about this on a much deeper level. And so this actually feels like something that has the potential to be looked in further detail and to grow over time. Your renderings, your illustrations are beautiful, and I think it feels a very sophisticated project. And this is something that I would like to see more of, and I think that's really what one is looking for in a dissertation. One wants that sense that this is something important and something that could actually solve a very critical problem. So a very impressive presentation.
Thank you very much for the comment.
So Sebastian, do you want to articulate more on this last image and how to imagine the landscape to operate? I think there is a very good approach at the territorial scale, but it would be good if you articulate more at the landscape scale or at the human scale, that we can see here the different areas are working or operating with the landscape.
Sure. I tried to visualize in this last rendering all characteristics of this proposed landscape, from recycling the e-waste by the people and the resulting pollution of air, soil, and groundwater. And then it's also people who can scan the terrain and retrifying a particle simulation to see where the accumulation areas are, and then sending this information to a print robot where the accumulation panels can be printed using the e-waste components, the useless, because people extracting just the valuable ones, and there are also a large amount of unusable components. And after printing the accumulation walls, there is installation into the landscape by the people to create the accumulation walls. And in the immediate vicinity of these accumulation walls, there are the extraction pools with its vegetation to remove the pollutants from the contaminated soil and groundwater. And by harvesting these plants, these pollutants can be removed from the site, and the harvested plants can melt it into ore to collect as well valuable metals. And also, the last sentence, what I can say is that it was very important for me that the people have a main task in this landscape, and that was the way I tried to finish this.
Thank you. Other
Thank
comment?
you.
I mean, I would have a few comments, but I don't know if Marco wants to go first.
Oh, please go ahead.
Okay.
Yes.
Well, Sebastian, thank you so much for this incredible presentation. I have to say the imagery is quite intense, very beautifully prepared, and I think you really worked very intensely on this topic. A few things come to my mind. So in general, the topic is so urgent, right? It is really about the remediation of our modern culture of, you know, overconsumption and careless tossing out of items. So I think what really is also visible is this, you know, social aspect of the site. No, on the one hand, obviously it's a landscape project. You've showed in great detail how you could remediate this area, and I think what would also be very important, besides looking at the site very closely, is also the context, you know, of the site in Accra. And what we cannot underestimate, I think, is that people make a living there, you know, recycling the waste. And I think it's really beautiful, if I understood it correctly, how you incorporate how these people would use the site, no, because they actually make a living with it. And I have one very maybe important reference. A few years ago, this artist Vic Muniz made this documentary. It's called Wasteland. Not sure if you heard about it. It's about the largest garbage dump in Brazil. And he went there over 3 years and he documented, you know, these garbage pickers. And for them, they're kind of, you know, outcasts of society. But on the other hand, they're, you know, they're making a living. They're trying to send their kids to school, and kind of waste is their life. And Vic Muniz, as an artist from Brooklyn, but originally from Brazil, he makes these really beautiful portraits with the garbage that they're picking from the site. So I would definitely just, you know, out of pure interest, recommend you seeing this, because I think it really captures the aspect of the people that are part of these sites. No, I mean, of course, it is really horrific looking at all of the terrible pollution that these sites also generate. And I think your project really captures this intersection. No, on the one hand, it's the landscape that is polluted, but on the other hand, you know, it provides a basic economy for people to make a life. And maybe more in general, you know, these projects, they actually address big issues that we have in our current society. And, you know, I would also maybe be curious, you know, looking a little bit outward, what you think should happen beyond remediating the site. No, do we want to give those people that work there other jobs? You know, we want them to become part of society in a different way. These are kind of the things that, or questions that opened up looking at your presentation. But honestly, very beautiful work. I'm very impressed.
Thank you very much.
Yeah, I think I have to join the congratulations, because it is in fact a beautiful piece of work. I have to say that for me, what is poignant is this ability you have to touch different chords in a way. There is a kind of poetic dimension almost to this garden that you have created, and on the other side there is of course a technological dimension, and of course a social dimension. And these elements, like Melanie was pointing out, I think they create they sort of unveil the kind of contradictions now behind our current patterns of production and consumption, but also it kind of reveals the complexity of the solutions. I think that, you know, we become, I think, more aware through your project that there is no like a single line of you know, of solution for these problems. And in that sense, I think perhaps what I would like to hear from you a little bit more is a kind of the bigger picture. You know, obviously the sort of tech giants that design and manufacture these products in the first place have a responsibility in all of this. Consumers have their own fair responsibilities. All of us, local governments, which in some cases are corrupt or are somehow influenced or under the so they have their own responsibilities. And so, I mean, in a way, I think that what would be exciting would be to hear your perspective on these, let's say, global power struggle or series of relationships. Not so much to come up with a solution to that, because obviously it's impossible, but more to maybe to get a sense of what you feel is your position in that. Let's say from tomorrow you are out of here in a way, and but you have this piece of work that it's your own tool to make an impact, or to begin to make an impact. And I think that in the spirit of the Synthetic Landscape Lab, as far as I understand, the work of researchers in the lab is always treated as something that should have an impact in the real world in a way or another, right? And I feel that in this case, how do you see yourself? How do you see yourself using this project as a tool to create, to move something in the real world? I mean, at what level and in which direction you would see this operating? Then maybe we can also ask Melissa for some other suggestion in that sense, because she's always has very interesting ideas in terms of how do you position your work. But I would like to hear your own point of view. Where would you feel like going with this in terms of making an impact?
I think with this project, you can. I think there are so much parts, and every part has its own function, and I think you can use like this technique of particle simulations and so on. You can use this for searching for polluted areas and creating some patterns or some materials which can counteract this kind of pollutions.
The knowledge that these simulations give you, how do you think it could be deployed? I mean, of course, on one side, it could be used to perhaps raise awareness or bring an extra level of an extra tool to the local communities or the recyclers, to perhaps enable them into evolving their way of operating. But I also suspect that it will be hard to improve that conditions if you operate only and directly onto the ground, if you want. I mean, I'm curious to speculate also if these are kind of techniques that speak a language of, let's say, speak the language of the digital world, that speak the language of design, etc., may be able to also strike a chord at a different level. I don't know if with the consumer category or with the tech company that produced this in the first place, and perhaps create a new possible synergies. I mean, of course, one could say, in the ideal world, you would like all mobile phones and computers to be designed to be completely recyclable and dismountable, etc., and that's obviously something that we could push for. But at the same time, you could also say, like Melanie was pointing out, there is a kind of economic logic to the recycling process that is taking place there. So what if the tech giants would actually support that process, investing funds in that, perhaps buying back these materials at the right price, therefore enabling an evolution of that process, so that in a few years' time, the same communities could be doing this recycling in a condition that doesn't imply the devastation of the natural environment and of their health, right? So, you know, there could be a kind of synergistic evolution of this process that is enabled by the level of awareness that your project brings. Not just awareness in terms of, oh, we know there is a problem, but really in terms of how can we begin to design this? And, you know, how can, I don't know, Apple, for example, become involved in designing the landscapes of recycling as much as they design the phones and the computers and so on. And so in a sense, I think it's, you know, you could begin to create like you've done, I think, a whole new idea of these kind of waste gardens where you extract these nutrients, but in this case also minerals and other particles from the land and kind of create a positive cycle out of it. So, I mean, this for me is the real potential of this. And of course, you know, it may take time for something like this to evolve. But again, I think what for me is important is that you kind of bring this narrative, this bigger picture into the project, because that's where I think the project is at its strongest in kind of leveraging the power of design and design innovation to create new synergies.
I'll just jump in there. I've got a couple of suggestions, Sebastian. So the first thing is that what your presentation so far, what your dissertation so far does, is it contextualizes the local problems. So you've done a very good job of showing the flows of the particles within this particular terrain. But actually, when you look at where the pollution is coming from, this is global. So for example, as you've probably watched the documentaries on this site, and they show that a lot of the e-waste, a lot of the computers and phones and other things that arrive at this site, they come from the United Kingdom, they come from the United States, they come from all over the place. So I think one thing that would be useful in your follow-on conversations and when you're actually showing this project is to have a couple of sketches that show these flows, show the global, literally global reach of, you know, where the pollution is coming from. And those are, if you like, inward flows. And what they show is that at the moment, the companies like Apple and, you know, all the majors, for all their talk of sustainability, they are essentially linear business models, because every single last one of them is still producing products that are not designed to be you know, they're not designed for the circular economy. They're actually getting harder to recycle, to disassemble, which obviously for this site here makes it actually harder for those individuals to extract the precious metals, the golds and so on, which is one of the reasons why there is this leaching into the landscape. So think about it. They don't have to be, you know, as polished as your illustrations here, but think about creating some flows that actually visualize that inward, you know, where the raw materials are coming from. Then also think about the fact that we know from this site that when the particles leach into the land and they leach into the air, they actually go into the river systems and they end up polluting virgin habitats, well, you know, what were virgin habitats that are miles and miles and miles away. And so they are potentially lethal. We know, for example, a project I've just recently completed on tire pollution. We've recently found out that with the issue of tire pollution, one of the polymers in tires is so lethal to animal life that it actually renders one fish species, at least one fish species, infertile. So that polymer, it's absorbed through the riverways. When tire runoff comes off the roads, it goes into the rivers, and there's a species, at least one, that is now endangered because of that polymer going into the roads. We have no idea of how immense the problem of the various polymers and other chemicals that are leaching from this site and going out to these incredible you know, habitats across Africa are. But that again could be something that you think about conveying in some sketches, because this is a potentially enormous problem. And the other thing I would say on this is that, you know, in the very act of doing that, you're highlighting what is the fundamental problem of the tech companies. But looking at your work visually, what these accumulation walls remind me of is lichen. And you might know that lichen is a primary indicator of pollution in a landscape. So for example, if there's very little lichen, that's an indicator of high air level air pollution, and vice versa. And it strikes me that though when we look at this picture before us now, this is a diagrammatic image that shows us the form of these accumulative walls. But what about if there was some indicator of what the pollution levels are? So in the same way that, you know, lichen shows what the pollution level is, what about if your walls did that? I think that that is something that as a scientific problem would probably be quite easy to solve, in that there are, you know, if you like, litmus reactions that certain indicators can have to particular chemicals. So maybe think about that, because that in itself then adds to the information facet of your work, but it's also something that has this very much organic and living feel, as opposed to something that, it's sort of a smart meter or something like that. If you've got something that self-organizes its indicative levels, then that is much more like a living system. And the other thing I would say is that with this project, if you were to think of how to get a conversation going, one of the primary places would be to get this before the tech companies, because bear in mind, they don't have this solution at the moment. They haven't been thinking in this way. So one of the things we could think about doing, and maybe with, you know, the rest of your team, with Claudia, with Marco, Maria, is maybe putting together an article that we put out on a platform where we know tech people are going to be. So for example, if I think to my LinkedIn platform, I have about 3,500 contacts on there, including senior board executives from many, many top tech companies around the world. So maybe put together an article that is a discussion piece, and it's not trying to solve every question. It's not trying to answer everything, because, you know, this is a very, very early stage project. But what it would actually be doing is saying, okay, so it's not the solutions here, the alternative thinking is not coming from inside of the tech world, it's coming from outside. Why is it coming from outside? Well, communities of people that work in very different ways and are looking at very different strategies have naturally taken a very different approach to how this could work, because it's by getting the conversations going that you open the doors. With something like this, to be honest, you know, you wouldn't be expecting a sort of a big Apple-like company to come along and say, right, we're going to snap you up and we're going to give you a great big budget, so go off and research this. But what it would do is it would actually highlight, you know, you are one of the problem solvers. You've come from a lab, you've come from a school that is a problem solving environment, and it would get those balls rolling. Yeah, I think that there's so much potential in this, and I totally agree with everything Marco and Melanie have said. So just again, well done.
Thank you. I also completely agree with you and Marco's comments.
If I can jump in, yeah, thank you very much, Melanie, Melissa, and Marco, for the comments. That's beautiful to hear this discussion after the year of work together. So, and now I think every time I really love to see the projects at the finals, because even us, who was working for a long time on the projects together, we see it maybe from a bit of a different position, or we see the kind of the conclusion of our work. And I absolutely agree with the social questions and the question of awareness and the next step that we need to tackle with the project. But I also like to see this project maybe not from the social position, not from the anthropocentric position, but what if we actually place the center to the landscape itself? What if the question is not the how does this community living there? That was actually the question that we were tackling in the project. But what if we now move the question to the landscape itself, and think that the landscape now is the first basically agency that we are designing for, and who is designing. And the technology, robots, human, and all these acts is just a part of the landscape organization, of the landscape choreography. Claudia was saying this word last time, and I really like that. What if, for example, landscape now owns all the trash and trying to deal with that, and using human and a robot in order to redefine it. And the landscape with all this trash it's kind of bought all that trash and now hiring everybody to recycle it, but recycle it in the way that is creating its sustainable and harmonic metabolism. By the way, it actually can do it, taking into account that there is a large amount of waste. And I think that's also interesting conversation, because then we are starting to think more like looking into the truly into the global scale as well, but maybe searching for the similar landscapes and thinking how similar tools, methods, recalculation, remetabolization could be helping different kind of the landscapes, biomes, and different regions on the earth to handle these problems, to tackle them, and to create a new ways of restructuring itself for, well, creating healthier cycles. So just to bring one more thought that actually, I think also supporting the previous one. Yeah. Thank you.
Thank you.
Thank you.
Thank you.
Sebastian. So we can go on with Daniel Stiletto.
Yeah, wait a second. Oops. Okay, so good morning, everybody. My name is Daniel Stiletto, and today I present to you my master thesis project called Atlas, Future Alpine Metropolitan Landscape. Atlas represents a design proposal focusing on the implementation of a highly efficient and sustainable way of collecting, storing, and consuming water in the Alpine region. As we all know, we have to face a large number of future challenges, like the climate change and with it accompanying extreme weather conditions as droughts and floodings. In this context, especially the supply and availability of fresh water is a crucial need of every plant, animal, and human being. This is why I focused on the implementation of a highly efficient water system for future settlements. We will see how water is distributed in and around the Alpine region and how we can improve and develop the terrain and settlement for the future generations. Investigating the Alpine region, we can see that the Alps are representing the water tank of Europe. Major rivers filled from glaciers and other natural water sources are providing fresh water and electricity to a huge number of citizens in different countries. In contrast, facing extreme weather conditions, we see that water runoffs are rising, bringing floods and devastation with them. Investigating the current water cycle, we have to improve our way of consumption and the way we are farming and producing goods. Choosing an investigation site was dependent on dense rainwater and snow precipitation, natural and artificial water runoffs. The Walchensee in southern Bavaria represents a combination of a huge water catchment area and existing water power plant network for the last 100 years. Around the lake, a variety of installations are providing power for the nearby metropolitan region of Munich, and the idea of an energy producing and water storing terrain was picked up. Digital analysis and observation of terrain samples were investigated and transformed into efficient water-storing terrains and dense tower-like structures. And now we will see how the manipulation of the landscape takes place. Monitoring the terrain's runoffs and water catchment areas, a tool was used to simulate the transformation of landscape into a continuous water storing and energy producing one. In addition to the existing natural lake water reservoir, the landscape around it is converted into a pond network along the local rivers and streams. To achieve an independency from the consumption of a large amount of land, a highly efficient water cycle is important. In order to generate a dense vertical water supply network, examples of water storing cells of plants and animals were analyzed. The network itself consists of nodes and pipes varying in density and shape, representing different programmatic infrastructures. Fresh water is supplied to the location where it is needed, and wastewater is drained to biological sewage plants before it is channeled into the foundation of the structure. By collecting and directing terrain's water runoffs, a huge amount of rain, snow, and ice is fueling the structures through the different seasons, fueling the foundation reservoir. Here, energy is produced through power plants and is then pumped up through a multi-stage system into the upper water storing spine. Thus, a closed water cycle is implemented. And now we will take a short look at the biosynthetic city itself. The outer and inner walls and cells are forming the habitat of the settlement in a new way. Vertical farms, apartments, parks, and ponds are integrated in the structure's cellular appearance. In this environment, we reduce our own way of living, inspired, for example, by the traditional Japanese lifestyle, and raise a global awareness of our future challenges. The Atlas concept provides the inherent potential to face future challenges using sophisticated architectural structures supported by a breathing biodynamic fueling system, consequently carefully managing the precious natural resources from ground to water and air. Subsequently, putting up more and more similar structures in strategic areas will provide the opportunity to give most of today's occupied territory back to nature, thus supporting the environment to recover and stabilize. Thank you for your attention.
Thank you, Daniel. We invite everybody to comment on the project. Who would like to kick off?
I'll kick off if you like. I remember seeing this project much earlier in its development, and what particularly impresses me is the extent to which the feedback and the advisories were taken on board. Compared, although this was a good idea in its an initial form, it is so much more sophisticated now. it's certainly in terms, I mean, diagrammatically, the visuals are stunning. You've got a very, very strong signature style here. I think you convey the flows, the essence, if you like, of what it is that you are communicating flawlessly. It's, I think, you know, as with the last project, there's a richness here. This is showing an intelligence in terms of its understanding of the environment. It's clear that your research has gone deep, and you have not just considered the local landscape and the history of that landscape, but you've actually looked worldwide. And, you know, as with the last project, although technically there are some, you know, unanswered questions here, and this is, you know, still something that, you know, in order to be, if you like, a doable solution, would need quite a lot more work to it. I think at the level, you know, that it's at, I think for dissertation, you have produced this work very, very beautifully. This is clearly the sum of a lot of hard work. And I think it's come together extremely well. It looks elegant, it looks compelling, and yeah, well done.
Thank you very much.
Maybe I jump in 1 second now. Yeah, Daniel, I think it's lovely to see how the project has evolved. I think the last time I saw it, there were a lot of elements to it that somehow made it harder to kind of read as a sort of narrative. And I think this presentation was a lot better in that sense. I know you as a designer, I think, have a really strong visionary drive, and at the same time you have a lot of influences that you have brought into the project. So the project, I think, compared to others, is a lot less, let's say, a one-liner in terms of the narrative, and it's much more driven by your design vision, I would say. And so, but at the same time, I think in this presentation you kind of managed to sharpen the narrative as well. So in a sense, the water cycle is driving it. We sense throughout the project that there are a lot more ingredients to it than let's say simply a kind of efficient way to think about the water cycle. But at the same time, the design language and the vision is what drives it. And in that sense, I think there is in my mind, a clear relationship with the kind of big transformations that the Alpine regions are undergoing. And I think maybe that's an element that could be good to unpack a little bit more. I mean, you really just touched upon it, but I think that that's in a way kind of calls for a bold intervention. And I think the fact that the scale of your landscape slash urbanism, like vertical urbanism, we can call it, it's huge, it's vast, right? But in that sense, we could argue that also the transformation the Alpine region is undergoing, on one side, due to the climatic effect on glaciers and the melting of glaciers, therefore like a huge amount of water being lost on the region. And on the other hand, of course, also the displacement of the local population, if you want, in terms of the kind of social and economic transformations of the areas. I think perhaps in the last couple of years, or in the last year, certainly for many of these regions, has been also extremely dramatic from the point of view of the tourism industry and the kind of economic impact of the COVID pandemic has been quite dramatic as well. So, I think what for me it's really interesting about the project is that like a region that, let's say the more conventional, distracted eye would just see as a kind of it's the realm of nature and fancy resorts and a kind of area that it's relatively untouched by the transformations of the world is undergoing. In fact, it is affected in a quite dramatic way at multiple levels. And I think in that sense, that kind of I wouldn't say justifies, but I think it gives a real context to why would you go for such a scale of intervention. And at the same time, perhaps it would be worth contextualizing it a little bit more in the vast scale of the engineering projects that dot the alpine landscape, because again, water has always been one of the crucial elements, whether for drinking, but also and mainly for the production of hydroelectric energy. You know, the Alps have been transformed dramatically through dams and systems of piping networks and hydroelectric plants and bridges and viaducts and so on. So in a sense, I think what your project for me brings very beautifully is perhaps another vision for how we may be able to extract resources, but at the same time also bring back, inhabit a landscape that for many years and generations have been inhabited and transformed by humans, but that at the same time today it's kind of considered very much outside the kind of a global problem and global issue. So in that sense, I think you kind of bring both these elements on board and somehow propose and suggest a scenario that takes it in a completely different direction. Last time, again, we suggested you to sharpen the presentation, and I think you did it, and that's great. But I think last time there was also a little bit more of a suggestion in terms of how this kind of structure, this almost like a artificial mountain kind of comes about. And I don't know, maybe that would be also interesting to know, although it doesn't necessarily need to be the focus of all attention or being resolved technically or technologically in its entirety. But for example, it would be interesting to see if you imagine this as emerging from a process of erosion or cracking of existing topographic elements, pretty much in the way as glaciers do or ice does. And and so it is perhaps something that is revealed by the disappearance of the glaciers, the transformation they leave behind, or if it's something that you imagine, let's say, being built somehow over the existing mountains and reliefs, or as a kind of dam, if you want, a new typology of dam, which perhaps work differently than the one that we are used to see. So again, maybe a little bit of that contextualization, it would just help us kind of anchor the vision into a few aspects of the landscape there and infrastructure elements of the landscape that your project redefines or rediscusses from the perspective where we are today.
Mm-hmm. Yeah, thank you.
Well, so I would have a few comments to your project. So first of all, Daniel, thank you for your presentation. I think, again, the visuals are so stunning. Last night, Maria sent me the link to all the issue portfolios. I looked through them beforehand and I was really impressed. So, I also want to commend you on your work. And maybe, water, the topic of water is so important. There are billions of people right now that lack access to water. And I think access to clean water should be a human right. And I think your project really should take that important stance, towards the topic of water. And now maybe getting a little bit further into your project in the Alpine region. So I'm a researcher at the ETH Zurich, and a lot of my colleagues, they research the topics of the Alpine region. And I would just have like a few comments to that, because there's this whole concept in Switzerland of the commons. No, it's like the commons basically defines a cultural and natural resource that is accessible to all members of society. And so, your project, I know, is about the landscape and how you store the water in these magnificent, objects. But I also think it would be really important to make a point about who can access it or whom is it for. Maybe there's like another comment I want to make, because if you look at the Alpine region, or if you look at Central Europe in general, you know, in our urbanization process, we actually have declining numbers. So I think with this topic of water, it would be important, which is what you do in your last drawing where you show the whole world. It would be really important to me how you would situate this project, addressing other areas that are in immense need of, you know, clean water. Because if you look at the Alpine region, it of course has been managed for, you know, centuries. You know, energy has been produced, dams. Now I think we have a very big problem with melting glaciers, because they actually release carbon into the atmosphere, right? So of course climate change plays a very important issue. And I think your project touches up on some of these topics, and I think some of these issues could be highlighted in a little bit of a different way. Especially also, you know, if you look at the Alpine region, the Alps itself, they're actually, I mean, if you look at Switzerland, for example, you know, they're not huge populations living in the intense Alps itself, but they're living more on the valleys and the bottom of the landscapes around the Alps. So I think this would also be an interesting way of kind of situating your project, no? Because how does it interplay with the urbanization process of the Alpine region itself? And yeah, so I think, you know, I can just commend you on your project, and, you know, I would, yeah, just be curious to, if you maybe have some comments towards some of the things that I just mentioned.
Mm-hmm. Yeah, sure. Thank you for your comment. So basically the idea of bringing up this kind of like structure was that we have a case study here at the Walchensee with the water catchment area. And we can see that this metropolitan region I'm speaking of, so we see, for example, Munich, Salzburg, or Innsbruck, the lake lies in between here, that these cities get more and more issues with the freshwater development as the cities are growing and forming a metropolitan region. And to fuel these cities, we can see, for example, here in this surrounding of the Walchensee, that farmers and agriculturists are having really big problems with lesser and lesser water throughout the years. And so the idea would be that we can set up new structures that are more efficient, having this kind of like vertical cities in strategic areas to really focus on this issue of the lesser water, because as I mentioned, for example, the Rhone glacier is one of these main areas where a glacier is supporting the water system, and with lesser and lesser glacier water, and we can see also that lesser rain is coming into the terrain itself, that we have to catch every bit of water for our future generations to inhabit the Central European area, I guess. And that structure idea could then further adapt it to other areas. Through new techniques, for example, the evaporation of air fluids. We can also do it in a desert environment, for example. So the idea is to set here this kind of like city structure, but we can also morph this with this technique a super efficient way in, for example, deserts in India, where we have big problems with fresh water availability, and we can scale it down, I would say. Yeah,
I would just jump in there. I think if you were to present this to particularly industry or anyone who's really working with things like policy, if you like, the key element, the key value from a critical solutions perspective in your proposal, is that obviously one of the great issues of our time is a change in the flow. So it's a change in the levels of precipitation. Basically, we have different amounts of snow and of rainfall to what we used to have. So, you know, we're moving out of the Holocene, we're moving into an era in which, you know, the flows are much more intense. So we kind of get an all or nothing scenario. And obviously at the level of the landscape, the consequences of that are really very serious. Of course, we have flooding, but of course we also have dam failures. We've got one of the biggest issues at present. Melanie mentioned about a lot of the communities in the alpine regions being in the valleys, is the risk of dams bursting, of actually structural failure. And what your proposal at its heart is doing is actually making interventions that modify that flow, that essentially, you know, rather than trying to pool vast amounts of water into great big reservoirs, is distributing this flow across the landscape. And that is a very interesting proposal. I'd say with respect to your megastructure, I'd be a little bit careful about your speculations with respect to how that interplays both locally and globally, because of course at the scale we're looking here, I mean, looking at the mountains to the side of this artificial structure, this is something that would actually interplay with the local weather system. So for example, we might expect fall clouds to be forming around the top of this structure and so forth. Unless you have those answers, you know, unless you've fully modeled or you've at least partially modeled how your structures would interplay with the likes of weather systems, and unless you have the answer as to, you know, quite how you are going to build these megastructures while mitigating the very same problems that dams all about the world are facing, I'd be very careful about how you pitch that, because it could look as if you're being, you know, rather ambitious given what data you have. But at the fundamentals of this concept, it's a very strong idea. And I think in that sense, actually pulling it out a little bit in terms of, yes, throughout all of your imagery, we see the flows, we see the water being distributed about the landscape. But what we don't really get in the images at the moment is a sense of this flux from season to season, from epoch to epoch. That might be something that's very interesting to bring to this, because that is what is happening. That is the reality of this situation. And that is really, you know, where the heart of the problem of present lies. And obviously, you know, that issue is not just applicable to structural failure of dams and other structures, or indeed geological failures, as I'm sure you probably are aware. One of the big issues with respect to why dams are failing is because the geology of these sites, of these mountain regions, is actually changing, because of course they're, you know, it's coming under much more pressure as the glaciers retract and so forth. That exerts, you know, massive amounts of kinetic energy release into the environment. And so, you know, we're looking at these sort of, you know, mega scale transitions in the environment that, although not quite that of the Ice Age, the end of the Ice Age, they're bigger than anything that certainly we've witnessed in human written record. So, you know, think about that. Think about how you might, not necessarily, again, you know, illustrate it in quite the detail and richness that you have in this, you know, visual we have before us, but how you would convey that, because that is the sort of question that you would be asked in a lot of environments. And certainly if you were to present this to anyone who has any degree of decision making in, you know, what is legislated in the likes of, you know, EU policy, and also perhaps think about the fact that, you know, at the moment, again, relating the flow issue to water availability, you know, you've mentioned water scarcity, but if you were to say, look at how many cities in Europe are going to experience a day zero within the coming 20 years. I mean, for example, we know that London is on a trajectory to experience a day zero within, you know, as little as 20 years. How many other cities about Europe will, and how does that relate to the change in the hydrological flows of the Alpine region. Because if you then pull in that data, if you can pull out a stat that says, well, you know, Berlin might reach day zero in year what, you know, X, Y, or Z, you know, Milan or, you know, Paris or wherever. If you bring that in, then you bring that sense of this being, you know, really relevant, and that you're really joining those dots, and you're really thinking, you know, in that, you know, granular detail about how your vision may actually work in practice within the context in which it's unfolding.
Yeah, thank you very much.
Thanks, Daniel. I mean, similarly to Sebastian, I think your project, of course, are both really accomplished in terms of visual language, and they work in somehow rediscussing what Anthropocene landscape are. So on one side, how pollution can be remetabolized and becomes contemporary landscape, how the Alps could become metropolitan and integrate this water flow. What I'm missing a bit in both projects is the resolution of how that happened in terms of material system and programmatically. That I struggle to visualize it in both your proposal at that scale. But other than that, I think they are both very accomplished projects at the territorial and let's say large landscape scale, and in the way they integrate issue of what is usually considered landscape or infrastructure with issue of inhabitation. So that is surely a strong point of the project. I would have wished to see more resolution at the scale of interaction between the human and the structure.
Okay, thank you.
Very interesting discussion. I just want to continue the project again. Daniel, it's infinite our work. You should keep going. So thank you very much, Daniel. Thank you very much for all the comments. So should we go to the project? Adam? Yeah, Thierry.
I'm there.
Start? Okay.
So, hello everybody. I am Thierry, and the thesis that I present is called the Fisarum game. It is a game mechanism and a slime mold-based system which should lead to problems in localities and to transform them in the best possible way. Here are some facts about global water. As you can see from the charts, the Earth has only 2.5% fresh water of the total stock, and that 2.5% is further subdivided, so that only a fraction of the fresh water is drinkable. To get to the point, we're going to look at the water in Cape Town. Cape Town has beautiful sites with the Table Mountain and the National Park. At the foot of the mountain, there are parts of Boca. As you can see, half of Cape Town is particularly surrounded by the South Atlantic Sea. In the first impression, you can already see the difference in the South Atlantic between 2006 and 2017. The same for the Three Waters Clough Dam. In these graphics, we can see that a lot of fresh water is lost. If you extrapolate it and consider that there is too little precipitation, in 2030 there will be a demand for water of over 17.7 billion cubic meters. To counteract this phenomenon, I will first introduce you to the first topic. Demographically, over 1 billion people around the world play computer games today. Today's topics include interactive storytelling, interactivity, and dynamic worlds, but in the thesis we will focus on the game mechanics. The second topic deals with the slime mold, called Fisarum polycephalum. It is a single cell with a diploid nucleus. It behaves and moves like a giant amoeba. Here is an experiment that I did with the Fisarum by myself and then tried to digitalize it. The digital version will later be used to expand various patterns and parameters. If you analyze the way you program a game, you come to the conclusion that you could project this pattern onto the slime mold. The next step would be to merge the two topics. In those experiments, I tried to give the Physarum several hotspots where it should grow to, but also some repellents. Those should be avoided. The graphics show that the Physarum grows in the direction of the attractors. In the second experiment, you can even observe that the slime mold finds its way out of the middle by finding the right spot. This Physarum machine is generated and is now being carried out digitally. The simulation on the left describes a system that is generated by individuals with similar interests. Based on the programming of common pattern, the individuals will follow similar path in the system. They will take approximately the same path in all simulations. The simulation on the right shows basically the same procedure, but with dots having different interests. Furthermore, an algorithm is used to support the connectivity. The red support line guides the player in one direction to look for food. If the efficiency is not guaranteed, the connection dies in this direction and another direction is taken. In this last figure, I want to show you that a lot of mechanics have been applied. However, the result is, like gaming, also guided by chance. Here, the sources, attractors, and repellents were always assigned different positions. And as you can see, the Physarum machine always grows differently. In order to turn the Physarum computer into a functioning system, it will interact with the morphology of Cape Town. The figures on the left is intended to create a basis and show how the process would combine various interests that would attract society. The right figures illustrate different thinking people living in the same city. Since they have different interests, the algorithm will take different paths that correspond to their interests. I divided the occurrences in the city. This works as independent layer and attractor. The figure below illustrates again how little water gets into the city. The Physarum machine moves over the entire morphology and networks all topics with one another. The different layers and teams have variance in the strength of the attraction. Starting with water, which has the most attraction, an entire network is created here. The aim is to bring as much water into the city as possible. Since the Physarum machine interacts with the city, a construct of water system is created. An overall network can thus be crystallized out. In this graphic, you can see that small agglomerations, where first of all, there is no water, but also where water is not needed. In order to create a new morphology that brings together all the mechanisms describes, the technique of picture-to-picture translation, also known as CycleGAN, is used. With this machine learning system, images are created from a collection of trained images from a source and a destination domain. The model of CycleGAN allows me primarily to reinterpret the city. The slime mold was shown away from where it should spread. Forbidden places were integrated in the Petri dish at various points so that it could not spread there. And as in the city, some agglomerations of people and places that are in absolute need of water were installed. For comparison, on the left again, the digital result that became the Physarum learning machine. On the right, the CycleGAN domain, which has resulted from a physical model and the map of Cape Town. Here is a figure to illustrate the created images for the end result. The focus here was on the city center. This results in a new interpreted morphology of the city center. Based on the resulting images, I can develop a 3D model. The heights I use to determine where water should flow and where land has arisen. Say the points that lie underneath sea level result in new sea, lakes, and rivers. The entire population is settled along the rivers and the water resources. In a final step, I applied the technique to the whole city, what generated a complete new morphology. I applied the same principle as for the city center map. In addition, the Physarum experiments and diagrams helped to discover the right places for the water pits that are now spreading through the whole morphology. The picture on this slide show how the morphology actually looks like. In the 3D rendered figure on the right is showing all the produced water pits. Here you can see from the pits how the water distribution has been set up. The pits result in rivers that bring a lot more water into the city than before. A new morphology has emerged, which is based on my thesis of the water shortage in Cape Town. The three main components, Physarum polycephalum, mechanism of gaming, and CycleGAN, create a computed machine that is able to learn and project what has been learned onto a morphology. So the map is reinterpreted, and as a solution, we get a new morphology that brings much more water into the city than the original. In the southern part of the map, I specify how the main parts of the map were redistributed. The water pits are always responsible as leaders. This network, the entire system and people needs are linked to it. New city centers and the rural towns are winded around the hotspots. The game interface becomes visible. This is how players become part of the event. After a short intro, the players can start right away if they don't want to read the instructions. In the first phase, the players can choose where they live and when their water resources are located. This distance between the two is then calculated. The interface calculates the attractors and repellents between the two coordinates. In order to get a result, the players are asked a number of questions that are intended to be used for the connectivity of the players. Depending on the interests of the players, they are more or less networks between the players and the water resources. In between, the player can look at the overall result of all the players. The total of the players is calculated to form an entire network. The player can resume the game at any time. If the player is completely connected to the network, the game is over. The stats can be displayed again. The experience points are calculated based on the water resources desired by the player. A simulation of Cape Town is shown, illustrating how the network of players could transform the city. In this figure, I want to indicate once again how the whole Physarum machine worked and has trained. This whole process ultimately leads to the result of the new morphology of Cape Town. This figure shows a part of the southern map with the main highlights. And this one shows a rendered top view of the water pits coming into the hotspots. In the last simulation, I want to point out the evolution of the morphology. Thank you.
Thank you. Thanks. Thanks, Thierry. I think there has been some very good progress in the latest months in the project. Are there any comments?
Maybe I can just quickly jump in and then. I mean, honestly, I think when the first time I saw the presentation of this idea, it was quite a while ago. Actually, I don't remember exactly, but I think it was quite a while ago. And to be honest, at the time, I couldn't see it. I couldn't see the. Well, I could see that there were interesting ingredients, but I couldn't see it coming together. It was hard. And then all of a sudden today I see this and I can, and it makes total sense to me. And also I'm really fascinated by the way you have merged different languages and different domains and actually made a proposal that is credible, but not only credible, I think it could really be an extremely important instrument for us, but I guess in this case for the wider public outside of the discipline to engage and understand with urbanism and the future of our cities. And the language that you have created, that is you know, kind of a morphs and merges together this the kind of biological patterns and growth pattern of slime mold on one side, and on the other side the urban realm and the satellite vision, and of course it kind of makes it rather playful by definition. Now I don't know, I cannot tell if the game itself as you have imagined it would be fun or not to play. I mean, I guess this will probably require a little more you know, test runs and so on to assess, but I think the way it kind of reimagines or allows players to reimagine their cities, you know, through the topic or through the lens of water, or it could be also other infrastructural element I could think of, makes it extremely compelling. And at the same time, I think there is also a deeper topic here that you have engaged with, because I remember when we started to do our own research on slime mold and you know, looking at the application of this kind of unique organism in computer science on one side, looking at the issues of cognition and intelligence, but on the other hand also in engineering, infrastructure engineering, the first applications to urban networks, you know, where perhaps on the Japanese side team looking at Tokyo network and so on. And you know, at the time it kind of felt really fascinating, but also in a way somewhat limiting the way the kind of a conceptual framework was deploying sounded and seemed very anthropocentric in that sense, and almost the slime mold was a kind of a understood as a sort of analog of you know, engineering techniques and strategies, and whereas I think that for me the fascinating elements of these organisms is the kind of mystery almost that is still behind its own unique form of intelligence. And I think what you have done here, coupling also with the machine learning tool to kind of visualize this intelligence and the consequences of this intelligence in the urban realm, I think it's really exciting, because it kind of explodes and in a completely turns upside down, let's say, the reductionist premises of some of these early experiments that we have seen, and sort of creates an open terrain for speculation, for imagination, for invention that you know, you really could drag in all sorts of different perspectives on how we should think or reimagine our cities, and the relationship between our cities and the living landscape that sustains them, and all the creatures that inhabits them. So it just makes it extremely creative and generative in that sense, not just in terms of the fun element that, you know, the game can bring, but also more, I think, profoundly at the level of you know, how we can essentially reconceive cities. What is the kind of a cognitive essence of contemporary cities, and you know, from a non-anthropocentric perspective. So in that sense, I think the project it's potentially really far-reaching in its conclusions, and of course, even in terms of its development, it opens a lot of opportunities, because as you said, you know, games are definitely one of the fastest growing industry, even more so in this period, and so, but you know, to be able to bring it back into the real world, let's call it like that, but you know, with such radical framework, I think it's really exciting.
Thank you.
Yeah, I'll add to that. I remember seeing this project again, as with Marco, a long time ago, and it was very problematic, and it was difficult to see how you were going to pull it together. but you took on board all the comments and then you have added to that. There are many things that are impressive about your presentation and your concept here. Again, you have taken an absolutely critical problem. Cape Town has already had its day zero, so you know you've addressed something that needs to be addressed. You also took a genre, as it were. You took slime mold, which over this past decade or so has seen a lot of research projects. Many of them have been very samey. There hasn't been much that has come along to really challenge anything that came before it, but you have done that. You have created something that is genuinely taking the idea of, you know, how we use biological computing to another level, to another place. You have beautifully spliced the living systems logic and the e-tech, as it were, the man-made algorithm into this this hybrid that, as Marco states, brings something that is genuinely you know, new to the landscape conversation. Looking at the visuals, I think there is a convincingness to them. They do feel very organic. They do feel to be very authentic. I think that, you know, technically this is a very, very strong project, and you've done really very well in the time that you've had. Your diagrams are really, you know, strong as well. I'd say if there was one thing that you could really add to this, and I'm not so much thinking about the landscape or the architecture or the urban community, but I'm thinking about how you would make this compelling and relatable to the public, to, as it were, your gamers out there. It's the fact that when we look at Cape Town in all of your visuals, it is obviously from that very bird's eye, from that satellite perspective. And we can't actually see in these visuals the monuments of Cape Town. We can't see Table Mountain. You know, we can't really make out the things that if you were a citizen of Cape Town, you know, you would relate to. And so I'd maybe think about trying to create some visuals. Again, they don't have to be polished, but just something that gives the gamer a sense of, you know, if my, you know, if my, you know, by my application, the output of my gaming experience were applied at the city level, how would the Cape Town that I know look different? Would you know, there be changes to the exterior of Table Mountain, or just a couple of images, because that is what makes it relatable. You know, just bringing out those things that people are familiar with, because, you know, many people will not be familiar with the satellite imagery of Cape Town. And so that, you know, that is just something from the perspective of getting engagement with the conversation that you're creating from the wider environment. But, you know, apart from that, it genuinely is a very exciting project. And I think, you know, you've done yourself proud. Great work.
Thank you very much.
Well, maybe I can take Melissa's last comment a little bit further, which I think is actually very interesting. If you look at South Africa in general, there are 7 million people that are locked out of the formal property market due to, you know, escalating prices and limited access to financing, so on and so forth. And as a result, all over, you know, South Africa, there are about 2,700 informal settlements that create poverty traps, because inside these settlements there's no social mobility opportunity, and there's a complete lack of basic infrastructure and services. So I think now with the game that you've developed, I would take on more the kind of complex issue that Cape Town as a case study would give to you. And maybe your game could even be about empowering, because what is happening that in these informal settlements, they're the ones that do not have access to water. So I think on the one hand, you were saying in Cape Town, there's the city center, and on the other hand, there are the rural areas. And I think defining this morphology a bit more and really understanding this inherent issue and lack of access to infrastructure, and especially water, would make this game very valuable. And then I think you would actually empower people in these informal settlements that probably today also have access to cell phones and maybe ways of actually playing this game, to help them overcome all of these issues that, based on the regulations of the city, they're basically cut off of basic infrastructure, no? And water, of course, is one very important infrastructure. So I'm not sure if you maybe had some more research on Cape Town itself, or if your intention was going a bit beyond this morphology of the city, which you defined as city center and rural. But I think there could be so much more with this game, and also with the way of using gaming to actually create urbanization. I think there's so many things that could be extracted a bit more. And maybe one more comment I have to kind of sum up my comment. In urban design, we actually talk about this top-down planning and the bottom-up planning. So I would really like to see this kind of biological game, to really empower people from the bottom up to help create their cities. And maybe you have some more comments towards this, but that would really interest me.
I'd just add to that, actually. Yeah, completely agree with Melanie. If you haven't already looked at his work, then look at Antonio Brillenberg's work, because his practice went into, I'm not sure if it was Kailicha or which of the which of the slums around Cape Town, but they went in and they actually looked at how they could bring in utilities they were actually looking at solar power, which the panels were on top of the roofs of the shelters. And they looked at how they could bring in the revenue streams and they could monetize that. And, maybe when you're thinking about where you might take this or how you might have that conversation with the wider community, look to their work and think, well, what could I learn from their work? How could I actually integrate some of the thinking in that work into my own work, and actually reach out to Brillenberg, because he's a very approachable guy. He's also done very interesting projects around South America and elsewhere. And I think that would help you to achieve some of the things that Melanie's just spoken to.
Thank you.
Maybe the work you have done with slime mold in that sense could also suggest you more of these, in a sense that I think what is really interesting about this biological model is that it kind of brings the conversation about the top-down versus bottom-up on a different level. In a way, it's really a different cognitive plane. If you look at it from the perspective of the slime mold, there is no such a thing as top-down and bottom-up, right? It's a monocellular organism in a way, right? But at the same time, its intelligence is not condensed in any particular place or unit, and it is very much embedded into the substratum where on top of which it grows. So, as you know, it is in itself a piece of flexible infrastructure with this kind of tubing, the plasmodium phase, reorganizing, but this reorganization only is made possible through the interaction with the substratum. So the information that the slime mold leaves into the terrain in the form of these traces is kind of retrieved at any moment in time, and it's a process that, of course, is a kind of emergent in that sense. And I guess the game could perhaps operate in a similar way, as a sort of as a platform can become a sort of substratum, right? Where players essentially leave and retrieve information, but at the same time, through that kind of interaction, perhaps can begin to self-organize or to communicate in a way that it wouldn't be otherwise possible. And so in that sense, the whole idea of infrastructure is redescribed and redefined. And water, of course, is a classic example, because it's probably one of the most fragile infrastructure, the way it is designed and implemented typically, and also one that probably is in need of innovation more than more than others. If you think about it, we are still very much using water infrastructure systems that are like hundreds of years old in their conception and functioning. So in that sense, I think that there is a really strong element there that, for sure could be investigated even deeper if you wanted to, but that can be brought into the gaming platform, whereas the platform, the gaming platform itself, becomes a form of shared memory or collective memory, and that allows for a kind of a new level of interaction and self-organization.
Okay.
I think the project has definitely done a great improvement, especially with not only the monitoring of the Fusarium polycephalon, but the development of a relationship between Fusarium simulation and machine learning simulation to the application in the site. So I think this methodological step was actually a great development in your project in the last period. It's still not completely clear how this is a game, but I think it's also on that level, the fact that you are introducing the aspect of gaming and connecting that to territorial planning as a relevance, as also a history. There are projects that we have been developed projects from other groups like CORE and etc. that have been looking at how we could interact with the master planning of city in a more intuitive manner, through visual value, through the recognition of pattern, and through a process that is much more like gaming than master planning. So I think that as an interest, maybe that part is not so developed as the workflow at the moment, or the case studies. But I think congratulations, because there has been a good development in that sense since the beginning. Thank you.
Thank you.
Thank you very much, Thierry, for the presentation. Thank you very much, everyone, for the comments. So that was the last project. Do you have any concluding words?
Thanks, everybody, for taking part and joining us this morning. Do we have some last remarks for the student or for the lab?
I would just like to say well done to all the students. I think you all did exceptionally well, and well done to Claudia and to Maria and the team for guiding and pulling this all together in these still very challenging times.
Thank you, Melissa. Thank you so much. Yeah, that's very challenging, but I think we managed quite well.
Well, if anything, I think the last year we've seen better projects than before. So maybe there is something that still works very well, despite maybe the remoteness. I think that there has been a lot of progress from what I've seen, and in particular, I think, as Melissa was pointing out, the diversity of the project is increasing. So this whole idea of a synthetic landscape is taking up so many forms, which are, of course, are reflected in the research that is conducted in the lab at different levels. But I think it's great that is sort of percolating through to the undergraduate level in the masters, and that we've been running, and then of course here in these thesis projects, you can see the evolution, and for me it's very exciting to watch, and so hopefully it will continue this way.
Yeah, I might also have a few remarks. So first of all, I want to commend Sebastian, Daniel, and Thierry on their work. I think you've done exceptionally well. And I also want to say, I think some of the discussions that we had today, they were on a very high level. So now, which only speaks to your work, I think Melissa made some great comments. It's really about how to get them out there. How do you now move forward? Now you're finishing your degree at TU Innsbruck. And I think there's some also exciting times. I know we're in a pandemic and it's very difficult, but exactly now I think we need these visions and ideas, and we need to find ways how we can communicate them, you know, to potentially make for a better world. And I also want to, of course, commend the teaching team, to Claudia, Marco, and Maria for, you know, supporting these students with this incredible work. I also teach myself, and it's, you know, sometimes a very big challenge, but I think the results are just stunning. And also thank you for inviting me. It was very interesting.
Thanks. So thanks a lot, everybody, for taking part. I hope we meet again soon. We are hoping to have in-person Defensio in June. We will see whether that will be possible. Thanks. Thanks, everybody. Maria, student, all the guests. Thanks.
Well done. Thank you.
Thank you very much.
Thank you very much.